This video is about nothing. Absolutely nothing. Is this nothing, or what about this? What truly is even nothing? Is nothing even possible or real? Well, yes and no. You see, nothing exists. Well, this kind of nothing. The word nothing means not anything or no single thing. We typically use the word nothing when we are referring to something that isn't there, or something that perhaps doesn't exist. For example, there is nothing in this glass. Well, is there really nothing in this glass? No. Although it may look like there's nothing in this glass, if I held it up to my nose like this, I would be able to breathe just fine. That's because there is air in this glass. Yeah, most of you guys probably already knew that, but there is something that you guys probably don't know. And that is, what is air made of? Air is made of 78% nitrogen, 21% oxygen, 0.93% argon, and 0.04% carbon dioxide. Air molecules only take up 0.1% of the volume that they occupy. Thus, air is a very sparse gas, meaning that 99.9% of the atmosphere is actually vacuum. But wait, if air only makes up 0.1% of the atmosphere, what about the other 99.9%? And what do I mean by vacuum? And what even is a vacuum in the first place? A vacuum is an electrical apparatus that by means of suction collects dust and small particles from... Who wrote this script? I did. A vacuum is a space in which there is no matter, or in which the pressure is so low that any particles in the space do not affect the processes that are being carried on there. It is a condition well below normal atmospheric pressure, and it's measured in units of pressure, the Pascal. For example, standard atmospheric pressure is defined as 101.325 kPa or kilopascal, and there are 1,000 pascals in a kilopascal. This brings up a question. How many pascals are there in space? Maybe space is the answer we're looking for. The pressure in outer space is so low that many human beings consider it as non-existent. Space has a pressure of 1.322 times 10 to the negative 11th power, which also equals 0.000000001 pascals. Yeah, super low. Does that mean that space is technically nothing? Well, no, but maybe space is the answer we're looking for. So is it possible to have a vacuum so perfect that literally nothing exists? No, because nothing does not exist. It is completely impossible to make a perfect vacuum. A perfect vacuum is described as a region in space that has no particles or atoms. And the problem with this is that a perfect vacuum would have to maintain a temperature of absolute zero, or 0 on the Kelvin scale. Wait, what is the Kelvin scale? The Kelvin scale was created by British inventor and scientist William Thomson, also known as Lord Kelvin. The Kelvin scale is one of the 3 best known scales used to measure temperatures along with Fahrenheit and Celsius. Like other temperature scales, the freezing and boiling point of water was used as factors in determining the range of the scale. In the Kelvin scale, there are 100 degrees in which water freezes at 273.16 Kelvin and boils at 373.16 K. And each unit on the scale is called a Kelvin rather than a degree. This is why a K is used in reporting temperatures in Kelvin. There are also no negative numbers on the Kelvin scale, as the lowest number is 0K, or absolute zero. The idea for the Kelvin scale was based off of a discovery in the 1800s of a relationship in between the volume and temperature of a gas. Scientists theorized that the volume of a gas should become zero at 273.15 Kelvin, or absolute zero. Absolute zero is equivalent to negative 459 in Fahrenheit and, as I mentioned before, negative 273 in Celsius. If you ever want to convert Fahrenheit to Kelvin, subtract 273 and multiply by 1.8 and then add 32. Then from Celsius to Kelvin, just subtract 273. So to create a perfect vacuum, we'd have to get the temperature of negative 459 degrees Fahrenheit, and we would also have to sustain that perfect temperature over a region of time. Also, the problem when creating a perfectly vacuum container, no matter how big or thick the walls are, there's always that finite possibility that certain small particles could still get in. So far, scientists have been able to create vacuums that contain less than a few thousand atoms, with the record being about 1,000 atoms per cubic centimeter. Which, if you think about it, that's not a perfect vacuum, but that's really awesome. For comparison, interstellar space, well away from the solar system, has less than 1 atom per cubic centimeter. And deep intergalactic space has less than 0.001 atoms per cubic centimeter, which is the closest thing to nothing that us human beings know about. And once again, thanks for watching.